We often use bar charts and pie charts to display categorical data, and we often use stem plots, time plots, and histograms for displaying quantitative data. Pie charts show the relative size of each value in relation to the whole. On the other hand, bar charts display the frequency on one axis and the values of the categorical variable on the other. You can think of bar charts as a way of tallying information. For quantitative data, we often use stem plots, histograms, and time plots to show information. We'll talk about histograms first. After collecting data from a population or sample, we can use a histogram to help us display the distribution of the data we collected. The frequency, or count, is displayed on one axis, and each count tells us how many data values fall within a predetermined interval on the other axis. This axis corresponds to the variable we have just measured. To read a histogram, you first pick one of the intervals and determine its height. So for the interval between 100 and 110, we see that the bar has a height of 8. This means that, from the data we collected, 8 people weigh between 100 and 110 pounds. For the next interval, we see that the bar has a height of 16, so this means that 16 out of the total people I collected data from weigh between 110 and 120 pounds. The rest of the histogram can be read in a similar fashion. A histogram is a form of a frequency distribution. Frequency distributions can be written in a table format, and they tell us how many data values fall within a certain interval. These intervals can be a little confusing. For example, if I recorded an individual's weight to be exactly 120 pounds, do I include them in this interval or this interval? By convention, we say that each interval does not include the right endpoint. So 120 is not included in this interval, and 130 is not included in the other interval. So in fact, 120 belongs to the second interval. Now you might be thinking, if the right interval isn't included, why don't I just rewrite my intervals like this? 110 to 119 and 120 to 129. Now the problem with this is that we don't have continuity. For example, if you weighed 119.7 pounds, there would be no interval that contains this value. Now a frequency distribution can be converted into something called a relative frequency distribution. The only difference between these two is that a regular frequency distribution shows a count, and a relative frequency distribution, as the name suggests, shows the relative frequency instead. It is called relative frequency because it represents the proportion of values in each interval in relation to the whole. To convert a frequency distribution into a relative frequency distribution, we will need to do some calculations. We start off by finding the total number of data values, and we do this by adding each frequency. We find that the total sum is equal to 50. Then, we will take each value and we will divide it by that sum. And as a result, we get the relative frequency values. To check if you have made the right conversions, you can add up all the proportions for each interval, and the sum should be equal to 1. The answer should be equal to 1 because we have used a ratio that relates our data to the total amount of data values. Because of this ratio, relative frequencies can be written in percentages. To convert to percentage form, all we do is multiply each value by 100%. In the same way, regular histograms can be converted into histograms that tell us the proportion of values for each interval.